Hi y'all. In this tutorial, we're going to be making a 2D player controller in Unity, which will let you jump around with the mouse like this. Jump. Now, I was inspired to implement this mechanic because it comes from one of my favorite games, Ronin, which is a little Kill Bill inspired indie title that I'm actually pretty good at. I just gotta click the I'm actually wearing a blindfold in this clip, so before we hop into Unity, let's go over the theory behind this jump mechanic. The jump itself is actually quite simple. When we want to jump, we just get both the player position and the mouse position in screen space, find the difference, tweak the vector until it feels right, and then add it to the player's current velocity. The hard part is making the telegraph. To do that, we need to calculate the trajectory of our jump, and to do that, we must drink from the forbidden well of knowledge, known to scholars as physics. Meet kinematics formula number 3, or at least that's what Khan Academy calls it. This baby can divulge the dark physics secrets that we so desperately crave. But it's a bit of an eyesore, so let's make it less mathy. That's better. So what this formula does is it takes the initial velocity of an object, as well as a constant acceleration, such as gravity, and gives us that object's displacement, or difference in position, after time t. Graphically, that might look like this. Now, this is most of what we need, but we don't actually want displacement. We want position. And to get that, all we have to do is add the initial position of the object to its displacement. And voila! We can now calculate where go from where was and where going, accounting for go down. Yes. Alright, so once you're in Unity, create a new 2D Unity project. I will name mine Mouse Jump. First, we'll set up our test scene, so make a new 2D physics static sprite. I'll name it Ground. Remove the rigid body, scale it up, and put it down. Then copy paste it, change the scale, put a few obstacles around to jump on. Then I'll group them all together for organization. Add a new dynamic physics sprite for the player, set the collision detection to continuous and the sleeping mode to never sleep. Add a line renderer for the telegraph and add a few test points. Then put the main camera under the player in the hierarchy as a child of it. Zero out the X and Y for the main camera, although keep the Z where it is. And then add a new box collider, make it a trigger, put it at the feet of the player. I'm going to name it grounded trigger, and this is going to help us know when the player's on the ground. Now make a new folder for the scripts, just for organization. Make a new C# script. I'll name it mouse jump. And then add that script to the player. And open it up. So first off, we will define all of the variables. First, the ones visible in the inspector. First is the jump button. This is just the Unity string code for whatever button you're using for jump. I'm going to use left mouse, which is fire 1. Next is a layer mask for all of the standable layers, i.e. the layers we can jump off of. Next is the grounded trigger that we just made, that 2D collider trigger. A couple tuning variables for jump, like jump strength, max mouse distance, which is how far out in the screen the mouse can be while still affecting the jump, how much of your previous velocity transfers into the jump, as well as the maximum sort of time or length for the telegraph, which you can reduce for performance, and the time between points that we calculate for the telegraph, which you can reduce for performance. And finally, the private variables, a couple components that we'll need that we will find in the start method later, a is grounded boolean that we can use to remember if we're on the ground, and a couple booleans to remember the inputs. Next, we fill out the start method where we just get all of the private components that we defined above, and we'll just get them from this game object. Okay, I'm going to have to go turbo mode for this next part because 10 minutes is not very long. All right, let's do update. First, we check if we're grounded. If we're grounded, then we get input. Otherwise, we reset input so we can't jump. Then we do jump stuff. We only jump if we're grounded, and either jump is held down or jump was held down last frame. First, we get the mouse position in screen space. Then we get the player position in screen space, find the difference, normalize the difference based on screen size, and then clamp it to the max. Now we've got what we need to telegraph and jump. So if the jump button was released, we jump. If the jump button wasn't released, we render the telegraph. And if no button is held down, then we hide the telegraph. First, let's write jump, which just sets our velocity to our calculated jump vector. And to find our jump vector, then we normalize our jump direction, add in our current velocity times velocity transfer, and then add in our jump direction times our jump force and strength. For the telegraph methods, we'll just put in stubs for now, which enable and disable the telegraph. And for update grounded, we check if the trigger is touching any standable layers.
Okay, turbo mode deactivate.
Alright, now we just have to finish setting up the scene. First we'll define what ground is, create a ground layer, and assign all the level objects to have the ground layer. And then for the player, freeze the Z rotation, because I forgot to do that earlier. Add the mouse jump script, and put in these values. I find they work well. Tune them to your liking. And finally, we can jump! And the telegraph is turning on and off because of those stub methods we made earlier. Now that jumping is working, then we can make the telegraph work for real. So first we will create a method called calculate position after time, which is just an implementation of that formula that we went through at the beginning of the video. And so it will take in the initial velocity and elapsed time, which were the inputs to the formula. So we start with the player's current position, and then add in the player's initial velocity multiplied by elapsed time, add in gravity multiplied by elapsed time squared, halved, and then finally we multiply that by gravity scale. Now, finally, we'll fill out the render telegraph method, which is going to actually draw the telegraph. So we start with the initial velocity, or at least our prediction, based on the player's current jump direction and jump force, or where the mouse is. Next, we will create a list of telegraph points that we are going to be filling out throughout the method. And we're going to initialize that at size of telegraph position count, which is the previous number of telegraph points, just to hopefully be a little more efficient. Next up, we're going to define the current point as our current location, as the telegraph should start at our current location. Then we will add our current point to the list of points and record the time at which the next point occurs in next point time. Then we will create a while loop, which will run until we break out of it or until the next point time exceeds the max time that we defined earlier. We will define the next point based on that helper method that we wrote above from the formula from the beginning of the video. We will find the vector from the current point to the next point, and then we will send a raycast out along that vector to check for the ground. This is how we stop the telegraph when it hits the ground. Then we have an if statement based on that raycast. If we hit something, then we are going to record that hit as the last point in the list, and then we'll break out of this current loop. And if we did not hit anything, then we are going to record the next point in the list. We are going to update the next point time, and we are going to update current point before continuing in the loop. Then once we have completely filled the list, we've traced the telegraph, then we will update the telegraph with these current points. And don't forget to set telegraph position count. And then finally, make sure to enable the telegraph. And finally, we have a working telegraph. It will show us where our jump arc is going to be. It's very accurate, and it will stop at the ground. Finally, we can make a few tweaks in the editor to make this look a little better. First of all, for the line renderer, we can change the width and make it fall off near the end. We can set the material to be the default sprite material and change the color to be a darker gray. And now, in my opinion, I think it looks a lot better. And this is the final product. Josh, I'm keeping that audio.